Okay, so we're gonna walk through one more example the whole way through. This one will have some coefficients, which doesn't change the steps we follow, but just makes it all the more important that you're actually following them. So 10 grams of magnesium react with 10 grams of oxygen gas, final limiting reactant, mass of the product. So notice I didn't say mass of water like in the last case, I just said product. You'll see why I can get away with that in this question, and mass of excess reactant remaining. So first step, as always, is to complete and balance our reaction. I'm going to go ahead and do that really neatly in a space where I'm not going to have to rewrite it, just so I can do my ice chart right underneath it, but whatever works for you is fine. So 10 grams of magnesium. Magnesium I know is Mg. React with 10 grams oxygen gas. Again, remember, don't let the word gas throw you, or I could have said magnesium metal, that shouldn't throw you. Oxygen gas is just oxygen, but oxygen's a diatomic, a Brinkelhoff, so we get O2. I see two elements here, so I have to figure out what to do with them. Two elements by themselves tells me this is going to be a synthesis reaction, which means I'm going to squish them together, but I have to look at their charges and crisscross. So some scratch work. Magnesium, look on the periodic table, is a +2. Oxygen, look on the periodic table, is a -2. So really those twos cancel out. If you do crisscross, make sure you reduce. We end up with MgO. So that 2 on the oxygen on the left-hand side didn't carry over. We're always starting over with charges and crisscrossing. So now I don't need that scratch work. I do need to balance this though. 1 magnesium on the left, 1 on the right. 2 oxygens on the left, so I need a 2 here on the right. That changed my magnesiums though. I now have 2 on the right, so I need a 2 there on the left. Okay, complete and balance my reaction, good. I need to find the moles of everything that I can. So for magnesium, I have 10 grams. This I can do off to the side. Grams of magnesium equals moles of magnesium times the molecular weight of magnesium, which is 24. 10 divided by 24 gets my moles of Mg to be 0.417. Again, 2 or 3 numbers after the decimal. If you just rounded this to 0.42, our answers will be slightly different, but you wouldn't lose any credit. Right away, I can go ahead and plug that into my ice chart. I also have my 10 grams of oxygen. Grams equals moles times molecular weight. This is O2, so my molecular weight is 16 times 2, or 32. 10 divided by 32 gets me my moles of O2 to be 0.3125, which I can also plug in my ice chart. Now, those are all initial values. Initially, I don't have any of my product. Don't start with any of it, so that's a 0. My reactants on the left side are always going to decrease. My products are going to increase. I'm making them, so I'll have more of them. This is going to be 2x because of the coefficient of 2 in front of the magnesium. This is just x because there's no coefficient in front of the oxygen. And this will be 2x because there's a coefficient of 2 in front of MgO. Now off to the side, I actually can go back up top if I want, where I have the moles there. I need to take those moles and divide by their coefficients, just not to change anything in my chart, but just to find out which one I'm going to run out of first. So actually, I'll go off to the side. Magnesium, I had 0.417 moles. I have a coefficient of 2, so that's from here and here. 0.417 divided by 2 gets me 0.21-ish, 0.2085, but whatever. For the oxygen, .3125, we're going to be dividing it by 1, so it's still 0.3125. That means 0.21 is smaller than 0.3125. Since it's smaller, the magnesium runs out first. It's just a coincidence that this problem and the last problem I showed you have that being the first column. You do have to do this work to figure it out. Okay, now I have a completed column right here. I have something in each row there, which means I am going to be able to figure out what my x is. 0.417 minus 2x equals 0. 0.417 equals 2x, divide both sides by 2, and I get 0.2085 or 0.21 is my x. For those of you who have noticed, it's not a coincidence that my x value is the same as that 0.21 number. That was what I decided was smaller earlier. I still think people make fewer mistakes if you show these steps out. I have my x value. That x can get plugged in everywhere in this ice chart. So to figure out the oxygen's ending value, I'm doing 0.3125 minus my x value, 0.21, which is 0.1025. I'll just round it to 0.103. For my MgO, I'm doing 0 plus 2 times that x value. So we're going to get 0.42 here. Cool, I finished my ice chart. I can actually go now and answer most of my questions. So for part A, what's the limiting reactant? That's the thing I ran out of first. So magnesium, Mg, or magnesium would be the answer for A. For B, I want mass of the product. Remember, product is whatever is on the right-hand side of the arrow. So if there were multiple products, I'd have to specify, I want water, I want magnesium oxide, whatever it is. Here we only have one product. MgO is my only product, so I can find the mass of it. Grams equals the moles from my ice chart that I ended up with, times the molecular weight of MgO. So 24 plus 16 is 40. I get 16.8 grams. For part C, I want mass of the excess reactant remaining. Well, the reactant I didn't run out of is O2. So grams equals the 0.103, that's what I have left over, times O2's molecular weight. 16 times 2 is 32. And we get 3.3 grams of O2. That's it. Go try one more.